In this video, we're going to be talking about linear functions. This is section 1.3, all about linear functions. So to understand linear functions, we really need to understand, what does it mean to be linear and what does it mean to be nonlinear? And so let's take a look at that first. So a couple of things to take note of here for a linear function is that it can be written in this form. This f of x equals mx plus b. Each variable on the function has a maximum degree of 1, and when the function is graphed, it's a straight line. So looking at things down here, you can see that it's kind of written in this form, right? And the variable on it is, the exponent on the variable is just 1. So that means it satisfies this. All right, so we just are looking at that, making sure that that is the case. Because notice over here, we've got an exponent where it's not 1. Right? And so this kind of helps us know that it is nonlinear. And so a function can't be written in that form if it is not linear. So it has degree of 2 or more, so meaning that highest, the value there, the degree of it is 2 or higher. If the variable appears in the denominator, right, that's making it a rational function, and so that's not going to be linear. If the variable is inside a square root, like this one, right, then that means it's not linear either. So paying close attention to what the equations look like will help us, but remember also if it's graphed and it's linear, it needs to be a straight line. If it's anything other than a straight line, then it's not linear, right? So here we can see this one is our linear function, right? The others are not. They don't make a straight line, so those are not linear. All right, let's talk about slope. So slope, we're going to kind of look at this. Slope is rise over run, is how we're going to look at it in the first place, right? And if we're looking at a graph and a line is increasing as it's going from left to right, that means it has a positive slope. If it's decreasing as we look at it from left to right, then that means it is a negative slope. All right, in these last two, people get confused all the time. So here we've got a line that's straight up and down, a vertical line, and a horizontal line. All right, so when it is a horizontal line, right, you're not going up or down as you're looking at it, kind of like we talked about these. And so this is where we have 0 slope. Right, so the slope is 0. But if it's straight up and down like this, then this is undefined slope. Let's see if I can write it along the side here. Undefined. All right, and so keeping those two straight in your mind is going to be really helpful. All right, let's use this idea of rise over run to help us figure out the slope looking at a graph. So first thing that we're going to look at is, how the graph is moving from one point up or down, and then what it's doing, going left or right. So if I look at this first one, I can see that if I go, if I start here at this point, and I just need to count how many places it's going to be to get us up there, because that's where we can see our other point is going to be. So it's going to go up 1, 2, 3, 4. So my up or down is 4, and it's a positive 4 because this was going up. And this time we're going to go to the right 1, 2, 3 places. And since it's going to the right, it's also positive. All right, so if it's down, then that's going to be negative. If it moves to the left, it's going to be negative. So now to write our rise over run, our rises are up or down, our left or right is the run, and so here we have our slope is 4/3. Okay, and then kind of similarly here, we can see on this one that we have, maybe I'll just do this one here. So we have this point, and it's going down 1, 2. So it's going down 2, so I need to put a -2 there, and then it's going to the right 1, 2, 3. So then my slope here is -2/3. Okay, so we can look at a graph. If we have 2 points on that graph, we can determine what the slope would be. However, sometimes we don't always have a graph for it. We are given 2 points. And so if we're given 2 points, then we can use this formula called the slope formula. This is one that you need to have memorized, right? Where m is the slope, and then x1, y1, x2, y2 are 2 points on that line. Okay, so for this first one, let's go ahead and let's use this slope formula. So this is my x1, y1, and my x2, y2. It doesn't matter which one we call like the first point and which one we call the second point, but just labeling it this way makes it a little bit easier. Okay, so to find the slope, m, we said we're going to do y2 minus y1. So y2 is 11 minus y1. Now be careful here because we're minusing a -1. Okay, and then on the bottom, we've got x2 minus x1. So we've got -12 is my x2 minus my x1, which is -1, so minus a -3. Whoops, did I say -1? I meant -3. All right, and then let's simplify this. So that's really going to be adding there. So I get 12 on the top, and then here I need to subtract those. -12 plus 3 is -9, and then that can reduce. 3 will divide into those. Oh, so I'd get -4/3 for my slope. And then I could graph these points, right? I could put these points on a line. So over -3 down 1, and then -12, 11. I know this is going off the grid a little bit here, right? Would be down here. But if you counted, right, you could figure that out. Or if you noticed, if you go, let's see. Oh, I went negative. Sorry, I did something wrong here. I could tell there was something wrong there. I'm trying to look and see. Sorry, it's -12, +11, right? So -12 this way, +11 would be up here. And so I can see that my slope is going to be negative, which is what I said it was here, right? And if I went down 4 and over 3 each time, I would end up right on that line. Okay, so you can count using a graph if you want to as well, or do it algebraically. It's nice in math that there's more than one right way that you can do this. Okay. All right, and I'm going to leave that next one for you to do. Figure out the slope. Remember, just label these like as x1, y1, x2, y2. Use the slope formula, and then also try and graph these points on a line, or sorry, on the graph, and then count to see what the slope is. Okay, so try it both ways there. All right, so the slope-intercept form of a line we're going to use a lot, and it is something that you need to make sure that you have memorized, and maybe it's one that you've heard before. Slope-intercept form of a line is the y equals mx plus b. All right, sorry, I kind of cut that off a little bit there. Let me try again. All right, and on this one, all right, the slope of the line is m. Okay, not the x. The x isn't part of it. It's just the m. And then the y-intercept is this b. All right, so we can easily see the slope and the y-intercept. So that's why they call it this form. So if I look at an example of this, you can see that if I want to define what my slope and my y-intercept is, so my slope, which I call m, is the number in front of our x, which is -5/2. So that's my slope. And remember, when I am dealing with this, that negative can go with the top or the bottom, but not both. And then my y-intercept, which is the b on there, is 2. Now, when we're dealing with y-intercepts, we want to write these as an ordered pair because this is a point, right? And so when I'm dealing with this, that would be the point that is right here. Right? That's our y-intercept. So that's over 0 up 2. So make sure you write this, understand how to write it as an ordered pair. And then to graph it from there, you can go down 5. So 1, 2, 3, 4, 5, and then right 2. And then if you connect those together, that would be the line. It's the graph of that, the equation of that line. All right, and then again on this time it's giving us the slope and the y-intercept, and it wants us to make an equation of a line. All right, so remember our line is y equals mx plus b. So it gives us that the slope is -4, so that's going to go in place of our m. So y equals -4x. And then my y-intercept is a 1, so I'll have +1. And so that is the equation of a line where the slope is -4 and the y-intercept is 0, 1. And then you could take some time and graph that over there just to get some practice with some graphing. Okay. Also, some other things. Here's going to be some review practice that I'm going to have you work on your own, which is, reviewing some of those concepts that we talked about up there. And there's a little activities and stuff that you can do as well. All right, the next thing that we need to talk about is the point-slope form of a line. And whenever we're writing an equation of a line, we can use this formula. Okay, so maybe I'm put up here, writing an equation of a line. All right, that's when we want to use this point-slope form. So make sure you get this memorized. So it is y minus y1 equals m, and then parentheses x minus x1, where m, again, is the slope, and x1, y1 is a point on the graph. So again, when we're looking at the name of this, point slope, all right, we need to know a point and we need to know the slope in order to use this formula here. And then standard form, you're going to see also, is written this way, where do you see how the x and y are on the same side of the equation, and then that constant term is by itself on the other side. So that's what we mean by standard form. All right, so let's do some writing of an equation of a line here on some of these that we're going to practice. So this time it tells us we've got a slope of -3, and it passes through the point -3, 5. So this is my x1 and this is my y1. And then I'm going to use this formula up here, this y minus y1 equals m times x minus x1. So this x and y in here, we're not putting any values in for that. That's part of our equation. So we'll have y minus 5, because that's our y1, equals m. Well, they give us the m is -3, and then parentheses x minus x1, and we can see x1 here is -3, so minus a -3. Okay, so be careful when you're minusing a -3 here. So that's really going to be add there, x plus 3, right? So let's simplify this to get it in slope-intercept form now. So we need to distribute that -3 through, and we'll have y minus 5 equals -3x, and then -3 times +3 is -9. And then to get y by itself, let's add that 5 over, which is going to give us y equals -3x minus 4. And that is the equation of that line. Okay, and I'll leave that next one there for you to practice with, given the point and the slope. All right, another way that we can write an equation of a line is with 2 points. All right, so remember, if we're trying to use that point slope formula that we were given above, that is y minus y1 equals m times x minus x1. All right, remember we said we needed a point and we needed the slope. Well, we have a point. We actually have 2 points. We have a point, but we don't have the slope given. But like we talked about above, if we're given 2 points, we can find the slope. So that's what we're going to do here. So I'll just write these down. So x1, y1, x2, y2. And then remember the slope formula was this, y2 minus y1 over x2 minus x1. So it's really important you remember the y's are on top and x's are on the bottom. So let's start with finding that slope. So if we do this, we have -1 minus a -4, so it's really going to be plus 4, and then over 3 minus a -3, which means we're going to have plus 3. So -1 plus 4 is going to be 3, and then 3 plus 3 is 6, and that will reduce to 1/2. Okay, so I found my slope is 1/2, and I have a point over here. So let's go ahead and use this point slope formula now to write an equation of a line like it wants us to do here. So y minus a -4 equals m, which we found to be 1/2, times x minus a -3. And then we'll do some simplifying here. We're minusing a negative is really adding. And so we have both of those things going on here. So really we have, I'm going to rewrite this as y plus 4 equals 1/2, parenthesis, x plus 3. All right, now let's distribute that 1/2 through. So we have y plus 4 equals 1/2 x plus 3, or sorry, plus 1/2 times 3, which is going to be plus 3/2. And then we need to subtract the 4 over to do this. All right, so let's just do a little side work over here, doing this 3/2 minus 4. All right, we need to get a common denominator. And so this is like 4 over 1, and I need my denominator to be 2, so I need to multiply both my top and bottom by 2. So I really have 3/2 minus 8 over 2. So 3/2 minus 8/2 is going to give me -5/2. So I'm going to put that over here. And so that is what's going to go here. So our final answer would be y equals 1/2 x minus 5/2. Right, and there is our equation of a line that goes through both of those points. Okay, and again, I'm going to give that next one to you to work on your own to try and practice. You could pause the video and work on them when I do this or work them later. Okay, now on this one, we want to write an equation of a line, but this time all we're given is the graph of the line. So remember, if we're writing an equation of a line in the y equals mx plus b form, m is our slope and b is our y-intercept. Well, those are the two things that we need to find on here. Well, I can see this is my y-intercept, and that looks like the point 0, 2. And then I need to find my slope. And so to do that, I want to, find a place. I can see right here, that's crossing, right at -1. So, and -2 there. So I'm going to write those numbers here. So that's the point -1, -2. And then I just need to kind of count to see going from there to there. So 1, 2, 3, 4 is my rise. So this is my slope. I'm going to just write it here. 4. And then over, let's see, sorry, so up 4 over 1. So 4 over 1 or just 4. All right, and remember my y-intercept is at 2, so that means I can take this. I know m is 4 and b is 2. So put that in here. Y equals 4m plus 2. And that's all there is to it, to write that equation of a line. So go ahead and do this next one, and then I want you to explain in words how you found it, just to make sure you're really understanding what you need to do to write an equation given the graph of the line. Okay, and I'm going to skip over this. We'll talk about that a little bit later in the semester. All right, so this we got to talk about, we're going to be talking about parallel lines and perpendicular lines. So parallel lines have the same slope. Right, parallel lines have the same slope. Oh my gosh. And they have a different y-intercept, where perpendicular lines have the slope whose product is -1, or we call them negative reciprocals or opposite reciprocals. So if I had something like -2/3, the perpendicular slope to that, we'd flip it and change the sign. So it would be +3/2. It would be its perpendicular slope. If I had something like the slope was 4, then the perpendicular slope to that, so this is kind of like saying 4 over 1, I need to flip it and change the sign, so that would be -1/4 would be the perpendicular slope. Okay, so make sure you understand how to find that perpendicular slope. So you got to flip and change the sign. And I'm going to put "and" in capital letters, so remember you got to do both. All right, and so then I'm going to let you graph these on here, but what I want you to see is when you graph them, they are going to be lines that are parallel to one another. Okay. All right, now we're going to write an equation of a line that passes through the point -8, 3 and is parallel to this line. Well, we can see right now this line is written in standard form, and so I need to get it into that y equals mx plus b form to figure out what my slope is. And then I'm going to use that point slope formula, y minus y1 equals m times x minus x1. All right, so let's go through and find what the slope is by isolating y. Let's get y by itself. So we'll start by subtracting the 2x over. So -3y equals -2x plus 10. And then let's divide everything by -3. So I get y equals Negative divided by a negative is positive, so that's 2/3 x. And then a positive divided by a negative is negative, so minus 10/3. Okay, but the only part of this that I want is just the slope. Right? I want a line that is parallel to this one, so the slopes will be the same, but that y-intercept is going to be different. Okay, so this is all I want, is that 2/3. So I'm going to write up here, we know m equals 2/3 from what we found over here, and this is my x1 and my y1. So now let's put it into that point slope formula and figure this out. So y minus 3, right, is my y1, equals m, which is 2/3, times x minus a negative 8. Minus a negative is really adding 8. And now if we want to get it in slope-intercept form, we've got to distribute this through and then add the 3 over. So I've got y minus 3 equals 2/3 x plus, and remember if I'm multiplying those together, multiply across the top, multiply across the bottom, so that's going to give me 16/3. And then I need to add my 3 overs to get my y by itself. But again, remember, let's do maybe a little side work. Maybe I'll do it over here. All right, I'm trying to figure out 16/3 plus 3. That's like plus 3 over 1. I need to get those denominators the same, so I need to multiply by 3 on top and bottom there. So I have 16/3 plus 9/3. And if I add those together, 16 plus 9 is 25, and the bottom stays as 3. So 25/3 is what my y-intercept is going to be. So I have y equals 2/3 x plus 25/3. And that will be the equation of a line that goes through that point and is parallel to this line. Okay, so go ahead and work out that next problem in the same way and find the equation of a line here. And now this next one, again, I want you to graph these on the same grid. And when you graph them, notice here, right, we got negative 2/3 is the slope of this one, and this one is 3/2. And so if I flip and change the sign, that first one, I do get 3/2. So when I graph them, they should be lines that meet at 90-degree angles. They should be perpendicular to each other. So just check for that when you graph both of those out. And now let's find an equation of a line that goes through the point 8, 3 and is perpendicular to this one. So same kind of things that we were given above, but now we want it perpendicular. All right, so when we solved this through, we found that our m, all right, above, we said our m was 2/3, all right, and that was if it was parallel to it, but we want the perpendicular slope, all right, so it was 2/3. This is the little sign for perpendicular, so I'm just going to put perpendicular slope is going to be, let's flip it and change the sign, so negative 3/2. So that's what we want to use in our equation. All right, so we're going to use negative 3/2, and this is my x1 and y1. So let's go ahead and put that into the point slope formula. Y minus 3 equals m, which is negative 3/2, times x minus a negative 8, so x plus 8. And now let's distribute that through. So y minus 3 equals negative 3/2 x. And now I need to do negative 3/2 times 8, all right? So across the top, across the bottom there. So that's going to give me negative 24 over 2, and negative 24 over 2 is negative 12. All right, so that's going to simplify to be negative 12, and then we need to add the 3 over, So I get y equals -3/2 x minus 9. And there is my equation of a line. So after you figure out this problem 13 and you know the slope where it's parallel to, use that slope and then figure out what the perpendicular one is to do problem 16.